All right, so we're looking at sine of pi over 4 being equal to k times the square root of 4 over 2. So sine of pi over 4 is equal to k times root 2. Sine of pi over 4 is root 2 over 2, and this is equal to k times root 2. Divide both sides by root 2, and I get k is equal to 1/2. Okay? Question 2. Question 3. This is the limit as x approaches infinity, so that is just 5/4. Question 4. Question 5. This factors to x minus 4, x minus 3. Just kidding. Minus 3 over x minus 4. Those cancel out, so f of 4 is equal to 1. Question 6 is an implicit differentiation. Question 7. So the derivative of secant is secant x tangent of x. The derivative of cosecant is negative cosecant squared x cotangent x. Negative cosecant cotangent. So it's not squared. So that is E. 8, 9. So remember that this is cosine of x, the quantity squared. So f prime of x is equal to 2 cosine of x times negative sine of x. So this is negative 2 sine x cosine x. And if you remember your identity, then you could have changed this into negative of sine of 2x, and then I can take the second derivative very easily. So that is negative cosine of 2x times by the derivative of 2x, which is just 2. So then I want this of pi, so then I want negative 2 cosine of 2 pi. Cosine of 2 pi is 1, so this is just negative 2. Question 10, question 11. Holy cow, we just did that. This one is in, it's a repeat of the one that's in your implicit video. So that is objective 2-17. And so you can go back. I just did the video on that one. So go back and take a look. I think it was question 1. Okay. There's question 12. Question 13. So f of x is equal to 5x to the 4th. The derivative is equal to 20x cubed. And I want it at 1/2. So 20 times 1/2 cubed is 20 over 8, which is 5/2. 14, 15. Lovely. Okay, so y times 3x squared plus x cubed times 1 dy dx. And then I get another product rule. So then that's y cubed times x plus x times 3y squared dy dx is equal to 0. So 3x squared y plus x cubed dy dx plus y cubed plus 3xy squared dy dx is equal to 0. So then I get x cubed dy dx plus 3xy squared dy dx is equal to a negative 3x squared y minus y cubed. So then dy dx is equal to negative 3x squared y minus y cubed, all divided by x cubed plus 3xy squared. Now I can factor out a negative out of the numerator and make it positive. So then that would be, looks like this one right here. Okay. 16, 17. So with a tangent line, the derivative is just 5. So you can't plug anything in for x, so it's just 5. 19. Okay, find the equation of the line that is tangent to the graph and parallel to the given line. Okay, so then that means that y is equal to 42x plus 9. So f prime of x is equal to 14x, and 14x has to be equal to 42 because the slope of this line here has to be the same as the slope of the tangent line. So then I get x is equal to 42 over 14. So that reduces by 7. That's 6 over 2, which is 3. So if x is equal to 3, then y is equal to... x is equal to 3. Then I get 63. So y minus 63 is equal to 3 times x. No, 42 minus... Yes. Okay. So 42 times 3 is 6, 12, 126. And that's negative, so 63. That's funny. So then that's positive, that's going to be negative, that's going to be positive, so it's going to be a negative. So 42x minus 63, which is that one there. 21, the derivative of this, negative sine 6x to the 4th minus 4 times by the derivative, which is 24x cubed. So this guy, 23. Okay, so for a vertical and a horizontal tangent, you have to take a derivative. 4x, excuse me, plus 4y dy dx. It's past my bedtime. Minus 20 plus 12y dy dx, okay, is equal to 0. So now I have 4y plus 12 dy dx is equal to 20 minus 4x, so dy dx is equal to 20 minus 4x over 4y plus 12. Okay, so 20 minus 4x is equal to 0. So then that's x equals 5. Okay, so it's one of these. And then 4y plus 12 is equal to 0. So then that's this right there. Okay, and that's it for this section.